I'll let you share your screen, and then I think we can get started.
Okay.
So go ahead.
Can you see it now?
Yes.
Shall I start? Can you hear me?
Yes, I can hear you.
Well, my name is Mario Mas. I'm working for MaxLinear. I'm a senior software engineer, and today we are going to present a unit testing workshop. This is going to be a presentation about how we do unit tests in the latest projects I've been working on. It's not meant to be a completely unit testing tutorial explaining what unit tests are or how they are written. There's plenty of information about these topics on the internet, and many people smarter than I can show you what a unit test is, and I think you may also know about these topics also. So it's meant to be just a presentation on how we have been doing this kind of things in the latest projects here at MaxLinear. I will start with an introduction. I will show you how we have disposed with our code to be easily unit tested. We move around libraries every time and everywhere. Our main concept is the library, and everything turns around the concept of a library. Then I will talk about the different frameworks and tools that we use for unit testing, code coverage, and memory checks, which are covered in the next sections of this presentation. Most of the time of this presentation will be dedicated to the unit testing section. Code coverage and memory checks are the easy parts of software QA, as we have designed our build process. We use Google Test and Google Mock for frameworks for the unit testing and mock parts of the testing. We will see some simple and naive examples on how a Google test looks like, and including another example with mocks as a way to substitute dependencies of the object under test. We will see also how to measure how many tests we have, if those tests are enough or not. If we have tested something and we don't have to duplicate that test, that's what coverage reports are for. To generate coverage reports, we use a tool called gcover. And in the last section, we will see how to perform memory checks with Valgrind. You might be wondering what memory checks have to do with unit tests. The answer is nothing, but they are included here because of the way we perform or we run those memory checks, because we use previously created unit tests and the Google Test Runner to perform the memory checks on the same run. First of all, we create a library. That's the way we organize our code, so it can later be unit tested. all the business logic that we implement has to be included into a library. That way, that library can be linked against a test runner. In our case, it's the Google test runner, and then unit tested. That library can be also linked against the command line application for test and demo purposes. That's what our software QA department does most of the time, use these command line applications. This library can also be used as is from other C or C++ or Python applications. That's the way we use our code, and it's more simpler to maintain. It's simpler to maintain because it's not duplicated. Once we have to add some feature or fix some bug, we do it once, and it's available for everywhere where we use that library. It can also be used through a JNI bridge from Java applications. In this diagram, you can see the architecture of the different components that we have in our applications. Bottom line is the library. The name doesn't matter for the presentation today. Just imagine whatever you like. It doesn't matter. It's where we put all the business logic, as I said, and then that business logic can be used from the other components. From left to right, we have the tool, the command line tool, which allows for testing, quick tests through the command line and see how our business logic behaves. We also create or can create higher level applications, more complex applications. We also use the library from our unit tests, which in turn use the Google test library, or through a JNI library, we can call our library from a Java application. You might be wondering how much does it take to create unit test for your code. I've been looking for the answer on the internet, and some people say that it takes the same amount of time and lines of code to write unit tests that to write the code under test. Well, I've checked that assessment, and I can say it's true. As you can see here, the library, which is the blue part, it's more or less the half of the effort, and the other half goes to the writing the unit tests for that library. The smaller section is for the command line tool I mentioned before. This is not a particular case for this library. I've repeated these measurements for other libraries in other projects. And the ratio keeps constant. It's about 50-50, the code we write for the library and for the unit tests.
Just wondering about the numbers you brought. In this calculation, does writing the unit test take into consideration the time you fix the code while writing the unit test? I mean, many times when I write tests, I find bugs during writing the test.
These numbers are only a picture of the result, the finished project. I mean, once the project was finished, I took this picture, and these were the results. I think I know what you mean. You are talking about the time it takes to write the library and the unit test. I cannot measure that. I cannot give you a number of that.
Okay.
it's we are going to talk on later on how we develop our code and our test, and it's a continuous process, and it's very tight together. I mean, it's not possible to write the library without the unit test, or vice versa, for me, as I understand it.
Okay.
Let's move on to the unit testing section. We will talk about unit tests and then mocks. As I said, this is going to take most of the time of this presentation. First of all, what are unit tests? It's not quite clear. There's no agreement on this. I've been looking for a nice definition, and I couldn't find it. I mean, many people agree on what unit tests should have, but sometimes it's contradictory. What is sure is that unit tests ensure that the section of an application, which is known as the unit, behaves as intended. I mean, it does what it was supposed to do. In our case, we use object-oriented programming languages. The smallest unit would be a method in a class. People agree on unit testing is white box testing as opposed to black box testing. I mean, code being tested is completely known to the tester, and he knows perfectly what test should be written. Another aspect is that tests should be automated within the build process to be really useful. I mean, this is unit testing is like a safety net, as many people say on the subject, because they allow to perform refactoring of our code, being sure that no errors are introduced while doing such refactors. Unit tests are performed by software developer themselves because of the previous item about white box testing, and everybody agree on a framework, a testing framework should be used and selected for the language we write our code. In our case, we have chosen the Google test framework because we mainly program in C and C++, which is also the case for prplMesh. Regarding pros and cons of unit testing, you can find plenty of them in the internet. Here I will list only my favorites. As an advantage is that unit tests allow for early detection of bugs when code is changing. You've probably suffered from side effects while changing your code, adding new features or fixing bugs, and then you alter your code in some unexpected way, which goes unnoticed maybe until months later, where it's really difficult to match that bug with the code or the change that introduced that bug. It's really difficult to find bugs or to trace it back to the changes that introduced them. With unit tests, however, as soon as you introduce a bug, you notice it and you can fix it. main limitation or disadvantages is that testing all paths is too expensive, sometimes impossible to be economically viable. Imagine a program to play chess. We should test every match, and it's impossible. It's impossible to speak about unit tests without speaking about TTD. TTD says that unit tests are created before the code itself is written. I tend to be not so strict with this assessment. In my opinion, or my way of doing things here is cycling between coding, testing, and refactoring. I do that in cycles until I have code that works as intended, and I have the unit tests that prove it. The key point here is to write code so it can later be unit tested. That's the reason we are going to talk about this later on. And this is also the reason why it's very difficult to test unit test legacy code, because it hasn't been written so it can be unit tested. Well, let's start with unit tests. As I said, Google Test Framework is being used. You can find everything you need to start with Google Test, and in that link, reading the tutorials is a must to start working with Google Test, and you can find there everything you need. Why Google Test and not other framework? Well, this was a decision I took some years ago when I had to choose a framework. At that moment, I compared what was available in the market, and finally I decided to go with Google Test. It was supposed to be the best option at that moment. You have to keep in mind that once you stick to one framework, later is quite difficult, if not impossible, to move to another one, because the learning curve, because the code base you have, which can make it impossible to move to another one, even if it's better. At this moment, I don't know of a better framework than Google Test, but well, I haven't checked it. Regarding continuous integration, what we do is to run unit tests automatically on each commit, and if merge is not allowed if all tests not pass. It's something similar to what we do in prplMesh with continuous integration checks, but applied to unit tests. This is something that cannot be left to the programmer, because he might forget to pass the unit test, or maybe he does a very small change and think that it has not affected anything else, and then he realized that something was broken because that small change. So this is the way that no bug can be introduced and go unnoticed. Well, this is the aspect that a unit test run has. It's like a list of unit tests, which the result and time is spent on each test, and at the end, a summary of the tests that were run with total time, and the test runner exits with a code that can be used to decide if unit tests pass or not, and then accept or reject that commit. This is like a template for writing unit tests according to Google Test. Every class under test must have at least one test class, which name is the same as the class, but with a suffix, so it can be identified as a test class. And then at the end you can see the different unit tests. At least should be one unit test for each method under in our class, which, as we said, is the unit, the smallest unit that we are going to test. Probably you will have more than one test for each method to test the cases where everything succeeds. It's the happy path, as may known, and other tests to test other paths in our method. That's why they have to be white box tests. As you can see, the constructor and destructor, or the setup and tear down methods, can be used to include code that has to be executed right before and right after each test. And this is an example, a very simple example of what could be a single test. As you see, what we do is to name the method, the test, with a method name that we want to test. And you see that that method appears more or less in the middle of the test. All the code that appears before that method is invoked is code to set up the context required to call that method under test. I mean, we have to create some objects, some parameters, some context to be able to call the method under test. Then we invoke that method, and we get a result, or we expect for an exception. We only can test methods that have side effects that can be checked against expected values. Otherwise, there's no way to check our method does what it was supposed to do. And finally, we verify that our code behaves as expected. Google Test provides for a lot of macros to test results. Here is the simplest one, which checks that the result code is has the value that we expect. It's equal to 0. If required, after all the assertions have been made, then we can, or we should, free allocated memory and resources if any. This is for advanced usage of the Google Test framework. This is one of the advantages of using a framework to run the tests. The advantage is that we have some features for free. In this case, we have command line arguments when running our test, which allows us for executing a subset of the unit tests. We can also run everything except a given unit test by using the minus sign before the filter. Now we move on to the mocks part, which is a way to emulate complex real objects while writing unit tests. General concept here is that we are going to use mock objects to replace the dependencies we have in our code under test. Mock objects implement the same interface as the real objects that we use in our test and in our production code, but they allow to run our tests and check which methods have to be called, in which order those methods are called, how many times, or with what arguments, and most important of all, mocks allow to specify inside each test what the mock should return in each call. This allows for testing cases, corner cases like a timeout or a duplicated packet which is received, or no response, things like things that with real objects would be really difficult to test. For that, we use Google Mock, which is an extension to Google Test for writing and using C++ mock classes. Only this, the existence of Google Mock, is a clear reason to choose Google Test over other testing frameworks, in my opinion, at least. As I said, we are going to revisit the concept of TDD. TDD means, as we said, write code so it can be unit tested. If we have dependencies, they are necessary. We cannot avoid them, but what we have to do is to not have tightly coupled dependencies in our code. We have to convert those tightly coupled dependencies into loosely coupled dependencies. And how to do that is by programming to an interface and by using dependency injection. Programming to an interface is writing our code in such a way that it depends on abstractions, on interfaces, and not on concretions or implementations. Put in other words is the dependencies must not be hard-coded. Or simply said, in our code, we should not call new to create an object, which is a dependency. All dependencies in our code under test must be supplied by another object, probably in the constructor or maybe with a setter method, but never, it has never to be created inside our code. Or otherwise, we won't be able to test that code without having that dependency also. Dependency injection is the enabler to use mock objects, which during test are supplied in the constructor, for example. Let's see a very simple and naive example of building a unit test, writing a unit test for an object that uses a dependency. Let's imagine for a moment that we work for NASA and we are going to write a unit test for a rocket launcher which uses a rocket. Rocket here is the dependency. Imagine an integration department which has to test our launcher, and in each test a rocket is actually launched. We couldn't afford that, of course. So the way to proceed is to replace that real implementation of a rocket with a rocket mock. First thing we have to do is to create an interface for the rocket object. An interface is nothing but a way to describe the contract, the behavior of the dependency. In this case, in our example, we will have a header file with a class, which is an interface, a C++ interface. It's a class with a virtual destructor, and all the methods are pure virtual. We don't provide any implementation for that methods here. Once we have that interface, then we can create different implementations for that interface. In our case, those implementations are C++ classes that provide a particular behavior. In our example, we can see that our implementation extends the Rocket interface and overrides all pure virtual methods that were declared previously in the interface. The C++ source file is not shown for brevity, it doesn't matter here. And then we will have to provide a mock for that object to be able to test our launcher without using our real implementation of that rocket. What we do in Google Mock is to create another class which extends Rocket, and with the help of these macros, we create a method for each method in our interface. This is a very complex syntax, but at the end we have a way to mock every method in our interface. We will see in the example how this, what is this for. Well, we have here our test for the countdown method in our Rocket launcher. We can see that first of all we create some mock objects. In particular, our Rocket mock object. Then we specify our expectations on those mock objects. We can specify them in sequence, meaning that the expectations have to be satisfied in such order. What we do is, for each expectation, we say which mock object and which method in that mock object has to be called. Google Mock lets us specify how many times or with which parameters, and most important of all, what will be the behavior of that call here in the very same unit test. Regarding our Rocket, we are specifying that the ignite method has to be called just once, and that no error is going to be returned, no exception is going to be returned. This would be the success case. Then, once all our expectations have been provided, then we create our launcher object. Be aware that all the dependencies are provided here. The launcher doesn't know if those dependencies are real or mock objects, because it's been written to use interfaces, not real objects. Those dependencies are provided here by the mechanism of the dependency injection. Finally, we call the method under test and check that no exception is thrown. At the end, when the mocks declared in the unit test go out of the scope, then Google Mock checks that all expectations have been satisfied, and throws an error, making the test fail if that's not true. As a summary, this is the most important idea in this presentation. What I wanted to say is that to be able to write tests for our code, that code has to be programmed in such a way that no real dependencies are being used, that we are programming two interfaces. And also that we use dependency injection to provide those dependencies, what allows to provide mocks instead of real objects while unit testing. Well, now we are going to move to the code coverage section. It's something very simple. Code coverage is like a measure of the degree to which the source code we have created is being executed when tests are run. But in other words, is an answer to the question, do we have enough tests or not? To be able to get coverage information, we have to compile our code with some special flags that tell the compiler to include coverage analysis and disable optimizations. Our build process automatically runs unit tests, and when done, it creates reports with a tool gcover. The output of this tool is both in HTML format, intended for humans, and also for the CI to let it decide if coverage is enough or not. What we do is to define a coverage threshold in such a way that if such threshold is not satisfied, then commits are rejected. This is to avoid that a programmer creates some new source code but forgets to include unit tests for it. In this slide, we can see an example of a summary report as generated by the gcover tool. You can see the number of lines that have been executed from the total number of lines, which give us a coverage percentage. This is one of the measures we have. The other could be the branches that we have tested. A branch is every condition that we have in our source code. This is because we can have a 100% coverage according to the number of lines, but not all the branches have been tested. Next, we have a list with all the files in our library under test, with a measure of the percentage of lines of code in each file that have been tested, and also branches. You can see the color legend. This is something that is configurable depending on how strict we are in our company. Then we decide those thresholds to be higher or lower. You have to keep in mind that there is some point while writing unit tests that to get 1 point in percent takes a lot of effort to get it. So it's difficult to know when when to stop creating unit tests. If we double click on whatever of those files, we can see a detailed report with green colored lines to reflect which lines have been tested. That means that some unit test has executed those lines. And we have red colored lines, which are lines that have not been hit by any unit test. After inspecting this detailed report, we know that we should include a unit test which can get to this red colored line and increase the percentage in coverage. And last, the memory checks, which, as I said, they are not directly related to unit testing, except for the way we run those memory checks. For memory checks, we use a tool called Valgrind. They are related because we perform the memory checks while we do unit testing. I mean, while we run the unit test, we also perform the memory checks. Valgrind is in fact a set of tools for dynamic analysis of source code, but we use only the memcheck tool that helps in detecting and warning about several memory-related problems. The most feared may be the memory leaks, or the so well-known memory leaks. Valgrind, what it does is to instrument our code in runtime to check for those memory errors, and as that instrumentation introduces a performance penalty, is not suited for production. Even it has to be used with care during integration tests because of that performance penalty and delays that it may introduce. What we do is to run our unit tests as a parameter of Valgrind. So Valgrind runs our unit tests, and while those unit tests are being run, Valgrind is checking that no memory errors are happening in our code. So at the same time that we unit test our code, we get for free a memory check. If we have a good coverage, then we can be sure that all or most part of our code has been tested for memory errors. This is also a deterministic way of checking for memory errors. And in this slide, this is an example of an error detected and shown by the Valgrind tool. What we have done here is to comment out a call to a free instruction just to introduce a bug. And what we have is like a stack trace of our code from the moment that that memory was allocated. We can see the file and the line number where that memory was allocated but not deallocated. And that way we can go to the problem and fix it. Well, that's all. Any questions there?
I have a couple of questions. It's Ran from Devalor asking the question. I also pasted my question in the chat if you would like to read them.
Which one, please?
In the chat, I just pasted the question itself, And do you have any design document for your test? Do you work closely to the requirements and expected results? Do you have documentation for the tests themselves? That's the question.
Sorry, I cannot get to the chat.
I just pasted the same question as I said. Do you have design documents for the tests themselves?
No.
No. Okay.
No, we don't have that.
Okay, so it's left to the developer itself to decide what to test.
Yes.
Okay, I see. And I have another question. I'll just paste it so everyone can read it as well. And the second question is, the limitation that you have for the merge process, doesn't it make simply for people to reduce the number of tests, just to disable or to test less because you are not allowing to merge the code?
We follow a code review process before merging. So if someone decides to disable a test, it's going to be noticed by the code reviewers. But also keep in mind that we also are running coverage reports. We are getting coverage reports. So if we disable a test, a failing test, to cheat the CI, then the coverage checks will notice that and will reject your commit because the percentage of coverage has been reduced.
Yes, that's what I thought, that you have a backup for such cases. Yes. Okay, thank you.
You're welcome. Any other questions?
I would like to know how you think we can use this in prplMesh.
Well, it's going to be difficult because what I said, code hasn't been written to be tested. So in order to do that, a lot of effort should be done to refactor our code to be tested.
Another question might be the code that you've written for prplMesh. Have you written it with unit testing in mind or not?
Yes, of course.
But yes. You have not managed to actually write a unit test for any of the code that you've added.
Sorry, Arnaud, can you repeat? Because the first time of your speech
I know.
is not understandable.
You have not managed to write a unit test for any of the code you added.
No.
Which I understand because it's difficult.
No, because we also have to introduce the Google test framework into our building process and then test it, of course. That's something that I would like to do, and I would like to seize this opportunity to propose to include unit testing. We claim we use an agile methodology to develop prplMesh, but we are not using unit tests. And that's something that go together. We should be doing unit tests for our agile approach to code development, in my opinion. What I mean is I think that the integration tests we do are not enough.
I fully agree. But I think unit testing should take, because we're working with real hardware, we should have every developer, like I said in my session, every developer should think outside the box and use the infrastructure that we have to test his code. Once we have the board farm or some other testing framework, we can enhance the unit testing to actually, for example, channel selection or auto-config. The CI will make sure that it's basically passing all of the, at least covering all of the parts that should be covered by the test bed. This is your point?
Let me, yes, I agree with you, but let me show you one of my slides. It's one of the first slides, this one. This is our architecture. The library that we were talking about is using other libraries that is not shown here, and I didn't mention it. Those libraries use or communicate with real hardware, in fact. What we have done is to create some kind of abstraction layer to make things independent from the hardware. This library was supposed to be used to talk with real devices through a network. And what we do is to mock those dependencies. So this library can be tested without using real hardware. Can be unit tested without doing real hardware. What you are proposing is more related to integration tests that done with unit testing. Both are required. I don't mean to replace integration tests we are doing now with unit tests. What I mean is we should complement integration tests with unit tests.
Yes, I do agree. They are different things, and yeah, we are not doing anything like unit testing yet, and it could be a nice addition. So I don't think we should go back and rewrite the entire code so that it can be unit tested, and then writing code unit tests for everything, because that will just take ages, I think. But it could be a good idea to do that in the future for new code. Yeah.
Yes, I agree.
Yeah. For instance, unit testing, like you showed, it can allow you to detect memory leaks, for instance, and that kind of thing is really difficult to test in integration tests or on hardware because you don't have fault grind there. But you can do it very easily in unit tests, and it's also useful for just testing that your functions perform according to their contracts, kind of. So it's a very different approach than a regular testing.
I have a question. Can you hear me?
Yes.
Yes.
So it was my understanding that the memory leaks is completely independent from the unit test. At least that's what I heard during the presentation.
Yes. They are not related. I mean, they are related only because we run unit tests under the umbrella of Valgrind. So we use unit tests to check for memory errors. At the same time that we run unit tests, we check for memory errors. And that's the only way they are related to each other.
Yes, like I mentioned, it's not that they are necessarily related. It's just that that it's difficult to run something like a memory checker on the hardware directly during your test. So you should really run that on a PC, and so it's really more suited to unit tests than to integration tests. in general. It's not that you can't do it during a different test or that it's some way related to unit tests. It's just unit tests tend to be the best place for it, in my experience.
Yes.
If I may add my point of view, I cannot agree more with all of you that we need unit tests, and we could even make it so that the certification test wouldn't run if the unit tests don't pass, because you could, for example, something like the channel selection is something that I think could be easily tested with unit tests, because we know we are going to have issues with them in the future. So I think it would be great if every time we notice an issue, we'd add a unit test for it, because it will be way faster to test than to wait for the certification test to run, because we know they take a lot of time. And thank you, Mario, for the presentation, by the way.
You're welcome. I agree with you. We could introduce unit tests as we need it from now on. Maybe refactoring all existing code is too ambitious, but for small parts, for tricky parts, we can create our unit test. It's a very easy way for a developer to know that the code he's writing is okay and behaves as expected. Otherwise he has to wait until that code is run in real hardware, and together with many other things. It's too late to realize of defects, and you cannot test every possible path. I mean, it's much easier to be sure that your method is working as expected if you do it by means of a unit test than waiting for it to be executed in a CI check.
Mario, is there any specific reason why you decided to use Valgrind? Because coming from open source, there is few possible options, like CLang has feature which is called scan build, which is useful too for looking for memory leaks, and basically using both of them at the same time may be more effective than using Valgrind alone.
Yes, I agree with you. We could use Valgrind or some other tool, or maybe both. As many tools as possible would be better. That's something we are working on, including more tools. We are also evaluating some other dynamic analysis tools. I don't know if you know about one which is called American Fuzzy, I think.
American Fuzzy Loop, AFL.
Yes. We are also evaluating that, but as always, it's a question of time.
By the way, had you a chance to check the prplMesh with Valgrind?
Me? No.
No.
No, I haven't. But it's a problem. You have to run prplMesh trying to execute all possible paths, and that's not deterministic, and that's very difficult to achieve. You cannot force prplMesh to go into every path, but with unit tests you can force it. Everything that doesn't depend on the hardware, you can test it, and you can test every path if you create a unit test for each path.
Would it be fair to say that it's also easier to replicate the defects? So, for example, we had on another presentation where we had the scenario, we had channel 6, and we had to repeat the sequence to get into that position. Would the unit test help us replicate these kind of issues more easily?
Replicate issues. Well, when you have a unit test failing, you can use it to pinpoint where the bug is exactly. You can also use your favorite debugging tool to run your unit test. You don't have to run your unit test in your platform, in your real platform. You can run them in Linux. So it's better from every point of view, in my opinion.
And also, when you have a lot of unit tests and there is then an issue which pops up which is not covered by unit tests, you can fairly easily extend some of the unit tests to check whether a theory about, okay, maybe this is wrong, you can check with the unit test whether that is really going wrong, and by adding a test. And if that test fails, then you have identified the issue. If that test succeeds, then the issue is somewhere else.
Yes.
And that's while debugging, you're also expanding your tests coverage, which is always a good thing.
Yes. I didn't want to extend my presentation with all the benefits of the unit tests. It could take a 3-day workshop presentation, and that wasn't the point. It was just an introduction and just to explain our approach here at MaxLinear on how we do things. Trying to make you aware of the benefits of using unit test, which I know you are. Well, hope you enjoyed it, and hope someone decides to use unit test in prplMesh. I'm looking to you, Frederick, because you have.
Yeah, we will definitely, yeah, I'm definitely interested, so we'll come back to it.
Okay.
Okay, so thank you, Mario, for that enlightening presentation. So to finish up, I just want to first of all thank everyone for coming. It's not easy sitting through an entire day of presentation. So thank you everyone who was here for the entire day. So I had some I'm interested in hearing your comments about the presentations and what we can do to make them even better. So I've already written down some things, like I think we should avoid things like we had this morning, where Shelley was not able to attend because she had some technical issues. So could be useful to do a rehearsal next time. That's one thing. And I also have the impression that presentations were not always perfectly tailored to the audience. Like the DCS presentation jumped right into the subject without really introducing it a lot, which might not have been ideal, which is my mistake, of course. I should have communicated that there would be people that were not really familiar with either prplMesh or with DCS in general. And I also don't know if the timing was correct. So what do you think? Did we have enough breaks between presentations? That kind of thing.
May I first comment on the previous thing about tailored presentations to your audience? I think it's for most people very difficult to estimate what the audience is, especially if you can't see them. So I think it's important that we, as the organizers, in the beginning of a session and maybe even during the session, make sure that we ask the audience if clarifications are needed or if it's at their level, because it's not going to happen automatically.
Okay, yeah, that's a good suggestion. Thank you, Arnaud. Are there any other comments or things we can do better?
I have a question. Yeah. I'm not so familiar with the Zoom tool, so I find it hard to write comments or to add comments or to have question in between or to interrupt the speaker. Maybe just that I'm not familiar with the tool.
Maybe just if you put your video on and just speak, then speak up. Just like ask maybe each presenter can say when it's time for questions, and if it's all the time it's okay to ask questions, then just speak up. Where to write stuff, I agree, Zoom is not very convenient. Yeah, there is a raise hand option, so it's nice. It's also very convenient to talk in Slack, where you can put markdown style comments and everything. So perhaps, Frederick, maybe we can open another channel, or just not to, we can open a channel for the workshop, for the face-to-face, where we can exchange ideas or talk in between sessions, like we did today.
Okay. Okay, that's pretty good. Good idea. Yeah. So let's just see if anyone else has some comments for now.
It's maybe also useful to keep on the agenda while we are in between the presentations. Everyone have meeting, so this is a very minor suggestion.
Okay, yeah, I've tried to do that, but maybe not always.
It was a nice idea.
Okay.
Yeah, maybe just send the agenda to everyone by mail, and then anyone can open it if he wants to check something.
I think it's already.
Yeah, you should have it in your agenda already through meeting invites, but sure, I can do that if you want it.
Maybe better in the specific Slack channel for the day or for the specific talk, not by mail.
Okay. Okay. That's useful feedback.
I want to give a positive feedback, because I think that it, with the teams from everywhere and many companies and some joining for the first time, I think it went really well. We didn't waste a lot of time on preparation and stuff like that. So I want to give good feedback on that.
That's very fair indeed, Adam. I think overall it went very well. So everyone did a good job, and I'm really proud of my team today. So thank you. Okay, so then I guess I'll see you tomorrow for the next session.
Bye,
see you
everyone.
then.